我问一下，你们学校上课用的是英语还是中文啊？
呃，都用。
哦，我们上课要不我们是用英文，因为那个那领导是说你那边还在学那个英语阅读啊这些嘛，我们就顺带就这些课开始也用英文算了
哦，
啊，
行。
就试一下嘛。你如果觉得英文效果不好的话，我们之后再换中文。可以。
好。
就你学校里反正也是要用英文的嘛，对吧？
我们学校主要是中教多，所以讲课是用中文，但是知识点的话是用英文说的。
哦，我们试一下吧，我们试一下。Secondary sales。上次我们讲的761哈。Okay, let's continue. In last lesson, we have learned the sales, the half sales. Let me check. Equation. And we have learned the concepts of the trains in ease of oxidation and reduction of elements. And in all, it had the list that the metals had the highest ability to oxidize. So it loses the electrons most easily, right? The metal. And second, we have learned that the more reactive metals can reducing the less reactive metals, right? Second one, like the zinc can replace the copper. Second, we have learned that by using the concepts of the redox reaction, we can build some cells. There are two kinds of cells. The first one is the voltaic cells, and the second is the electrolytic cells. The voltaic cells, it can occur spontaneously without energy supply. But the electrolytic cells, if we want to build it, we need to use the electricity energy to drive it. And for both types of the cells, the anode of the cells have the properties to oxidate, right? It will lose the electrons. And the cathode, it can get the electrons to reduce the electrode. And we have learned some kinds of the voltaic cells. The first one, the primary cells. The primary cells mean that it can only use once, right? It cannot recharge. When the electrode used up, the cell could not use anymore. So this is the primary cells. And for the voltaic cells, it can generate electricity from spontaneous redox reactions. And all these voltaic cells have two parts. Every part we call it the half cell. The half cell. The half cell. To build the half cell, the general method is to put the metal into its solution, right? Sulfate solution. For example, we use the zinc metal strip to immerse it into the zinc sulfate solution. This is a hard cell. And this is the copper. Copper, we use the copper metal strip and put it into the copper sulfate solution. This apparatus is called the half cell. And every half cell have this half reaction equation. The metal to lose the electrons, and we have the symbol with both arrows in it. This is the equilibrium reaction, right? So at the equilibrium, the left part and the right part reactions are equal to each other. They stay stable. This is the half equation of the half cell. And if we connect this two half cell with the wine and the bridge, then we build the voltaic cells, and we can use a voltmeter to test the voltage of it. So just like this, the zinc and the copper, we get the volt between them are 1.1 volts. And at this apparatus, the zinc part, it loses electrons. So it's the anode, right? It's the anode. And it has it occurs the oxidation reaction. On the copper part, it gets electrons. So it's the cathode with a reaction of reduction. And because this part, the electron is flowing out, so it is the positive part, right? Positive part. And the other one is the negative part. We can see the electrons. The electrons are from the positive pole to the negative pole. And for the salt bridge, we have the ions from the cathode part to the anode part. And the formula can write like this. The two part between the two half poles is the salt bridge. And we need to pay attention to the status of them. We need to write the states of the electrons and the elements. And we know that different half cells have different voltaic voltage. We can use the voltmeter to test it. And we know that this volt is a potential difference between the two electrodes, right? It's the potential difference. It's not it isn't an absolute value. It's just the difference between the two poles. So we need to set a standard, right? We need to set a standard. Just like we test the height of a mountain, we need to set the standard at the zero meter part. Actually, we use the sea level, right? We use the sea level as the 0 meter point. So based on this line, we can test any mountain's height. In the chemistry, we can test the voltage of any half cell by set the zero potential part. If we set the zero potential point, we can test the absolute voltage of every half cell. So how could we set the zero potential point? We use the concept of the, okay, we will talk it later. And there's the second cells. Second cell, we mean the recharge cell, right? Recharge cell. The example is the lithium ion battery. We use in the computer or any electric devices. And the third one is the fuel cell. These two kinds of cells, you just need to know them. You don't need to grasp the base knowledge of them. Okay, here's a comparison between the two types of cells. Okay. In today's lesson, we will introduce the second type of cells, which called electrolytic cells. Electrolytic cells, we have learned it before that it needed the electricity energy supply to drive the chemistry reaction, right?
Mm-hmm.
Okay. So how to build the electrolytic cells? It built like this. We set the electrolytic and put two electrodes into it, right? Two electrodes into it. And one electrode, it will lose electrons. And another one, it will get the electrons. So this part, which lose the electrons, are anodes. And it will connect to the positive pole of the energy source. And this part is the positive one. Okay. This is opposite to the voltaic cells. In the voltaic cells, the anode pole is the negative pole. But in the electrolytic cell, the anode pole is the positive pole. Okay. This is a difference. And another one is the negative part. So we can see from the graph that this cell needs the energy supply. Okay, we can have an example. Actually, the electricity we used is to reverse the lateral direction of change. In the lateral direction, we can have the sodium with the chlorine to react to produce this one. And in the electrolytic cell, we reverse this reaction with the help of the electricity. So it could okay. Actually, when the salt we put it into the water to make a solution, it will ionize like this, right? The cell will produce the two kinds of ions. But if we use the electricity supply, we will reverse this reaction. We would make these two kinds of ions to produce the elements of them. For example, here is the molten salt. And in the molten salt, there are two kinds of ions, the Cl and the Na+. When we put the electric supply in it, and the electrodes, we will use like the carbon or anything else. If we supply the electricity, for example, the negative ions will be attractive to this part, to the positive pole, and the Na+ will be attractive to the cathode. And we will inverse the lateral direction of this one, and to produce the elements. As a cathode, the Na+ will get the electron to produce the sodium. And on the anode, the Cl+ will lose the electrons to produce the chlorine. If we combine these two half equations together, we will get this one. Like this one, right? So we know the chlorine is a gas, and it's a green gas. So at the anode part, we will get the bubbles like this one, right? Green bubbles. So this is the first type of electrolytic cell with the molten elements. The second type we used is to using the lead bromide. And we use the graphite to produce the electrodes, and we supply the electricity to it, and we can ionize the solution of the molten the lead bromide, and to produce the lead and the bromide. Okay, this is the first part. We use the molten elements to produce the cell. Let's look at the second one. Second one, we can oxidize the function groups in the organic compounds. So in the organic compounds, we can also use the redox to oxidate the functional groups. Okay, let's talk about the organic compounds and the functional groups. Do you remember what's the kinds of them? What's the concepts of them?
Concept. Alcohol.
What's the organic compounds and what's the functional groups?
Compounds. About
Okay, we will continue. The organic compounds is that it is the compounds produced by the carbon and the hydrogen, right? Carbon and hydrogen. This is the organic compound, and the functional group is actually like this one. We use for example, the 2 pounds cc and the 3 pounds cc, or the COH or COOH. But this one, they are called the function group, right?
Yeah.
We use this part to lane these organic compounds. So in this part, we will talk about how to oxidize this part, the functional groups of the organic compounds. Okay, we will have two examples. The first example is the oxidation of the alcohols. We know alcohols have the function group of OH, right?
Yeah.
OH. Okay.
OH.
So if we oxidize it, which means it will get the oxygen, right? It will get oxygen. So how to get the oxygen into the functional group? Well, we will look at it. We will check it. The first one, this one is the ethanol, Hello. And we know this is the primary alcohol. Primary means that we use the hydrogen. We use the hydrogens. We use the number of hydrogens to name the primary or the secondary or the tertiary, right? Tertiary part. If the carbon connected with two hydrogen, it is actually a primary one. If it only can connect with one hydrogen, it is secondary one. And if it doesn't connect to a hydrogen, it is a tertiary one, right? Tertiary one. Okay. For example, this one, the alcohol, this carbon is connecting with two hydrogen, so it is the primary alcohol. So how to get the if we get the oxygen to it and with heat? First, this hydrogen and this one, they will get out to produce the water, H2O. And at this time, the carbon has two empty orbital, so the oxygen will add to here, and we get this one. This one actually is aldehyde, right? Aldehyde.
Yeah.
Has a CO and H and CH3. And the second step, we plus the oxygen again with heat, and we do the reflux. We will talk it later. What is reflux? In this part, the second hydrogen will get out, will be removed, and the oxygen will add at this orbital, and the other orbital will connect with the hydrogen. So it will produce this one. This COOH actually the acid, right? Carboxylic acid. So for the alcohol, for the primary alcohol, its oxidation has two steps. The first step is to produce the aldehyde, and the second step it will produce the carboxylic acid. This is the primary alcohol's oxidation. And we will talk about the reflux. The first step, apparatus is like looks like this one. We give the heat to the alcohol, and the alcohol will evaporate, right? It's a gas alcohol. Gas alcohol, it will flux here, press here, and these two pipe. One pipe is the input water pipe, and the other one is output water pipe. So the cold water will come here, and we and we can see there's a space between the inner pipe and the outer pipe, right? So the water will get into this gases and to cold this alcohol gas. So the alcohol gas will become water again, right? Become liquid again, and we can collect it here. So in this part, we can get this one, aldehyde at here, right? Aldehyde at here, and this one is a mixture of the alcohol and this one, Cr2O7. So this mixture, when we give the heat to it, it will produce this one, aldehyde. And the aldehyde has lower boiling water. That's why in this pipe, it's the gas of the aldehyde. And we use the water to cold it. It becomes liquid again, and we gather it here. This is the first step. Second step, we will use the aldehyde, use the reflux to produce this one. So it will use the apparatus like this one. In this port, it is the aldehyde with this one again, Cr2O7. This provides the oxygen ions. So it is also the commixture. It is also the mixture of this aldehyde and that Cr2O7, and we give the height to it. We give the heat to it, and in this part, this mixture will produce the gas again, right? Produce the gas again, and we also use the cold water. This is cold water in, and this is out pipe. So this gas will become the liquid again, and it will drop below it. Actually, drop below it. It is actually some carbonic acid. This apparatus is called the reflux. Okay, so do you have any question about this first type's oxidation?
For second step, the oxygen is to the hydrogen.
The oxygen, no, not oxygen, just this one, Cr2O7. It is actually the solution. It is mixed. Yeah, it is mixed with the aldehyde. Aldehyde. So just in here. Actually, it is a liquid. The liquid is a mixture of the aldehyde and the Cr2O7. So the oxygen is coming from here, coming from these ions. When they are mixing, and if we provide the heat, the reaction will occur to produce this one. And this acid has very low boiling point, so it will evaporate as gas. But we don't want them get out, so we will use the water to cool it. It will become liquid again, and it dropped here. This apparatus is the reflux. Do you have any other question?
No, next.
Okay, we'll go to the next one. The next one is the secondary alcohol. In secondary alcohol, the carbon only collects with one hydrogen, like this one, right? This carbon only collects with one hydrogen, so it is the secondary alcohol. Secondary alcohol, if we mix it with actually it is also Cr0 iron. It will provide the oxygen iron. So if we mix them together, and we give them the heat. The first step, this hydrogen and this OH will be removed to produce the water. And so the carbon has two electrons left. These two electrons will come with the oxygen one. So the oxygen one will be added to this spot and to produce this structure, CO. And this is the propane, propylone. In Chinese it means 铜，对吧？铜。Okay, so the secondary alcohol only have one step, right? Only one step. And this step only use the reflux. We can produce this one, propane. And with the water. Okay, did you have any question about this one?
Yes, no.
Okay, so we can see that every step we can remove one hydrogen. So the primary alcohol we need two steps to remove the two hydrogen. and to get the oxygen, which is the process of oxidation. And the secondary alcohol, we only need one step to remove the only hydrogen. So we will move to the tertiary alcohol. The tertiary alcohol has no hydrogen connected with it. For example, like this one. We can see this carbon connected to another carbon and another oxygen. So there's no hydrogen connected directly with it. Therefore, it could not occur. It could not occur with the oxygen ion. So it could not occur. No reaction of it.
Oh.
Okay, we can use this method to identify the different kinds of alcohols. For example, we know that the CrO7, the with the potassium, this one, actually it is orange at the very beginning, and if it lose the oxygen, it will become the green. So we can use this one to test the different kinds of alcohols. For example, the primary alcohol, secondary, and tertiary alcohol. We mix them together with the CrO7, and we provide the heat to them. The first two kinds of alcohol will occur with the CrO7. So the CrO7 will turn to green from orange. But the third one, the tertiary one, could not occur, so it will keep to be orange. Okay, we will not do the exercise because the time is limited. We'll move to the next one. The next one, we will introduce the reduction of function groups of oxygen compounds. We have learned the meaning of the function group and the organic compounds. In the last part, we will talk about the oxidation, which means plus the oxygen to it. In this part, we call the reduction. Reduction we mean that it loses the oxygen or plus the hydrogen, right? The oxidation just the opposite. Just to be the opposite, it is plus the oxygen or lose the hydrogen. So in this part, we will talk how to lose the oxygen or how to add the hydrogen to it. First one, we will actually this part is the reverse reaction of the previous part. So we will talk about the first one. If we get the acid, the carboxylic acid, like this one, we plus the hydrogen in it. We provide the hydrogen ion to it. And this hydrogen ion will get the aldehyde of it. Actually, this one, we can write its Lewis structure like this one. This COOH, like this one, right? This one, OH. If we provide the hydrogen ions, these hydrogen ions will combine with the OH to produce water. So by means of this one, we will get water and we will lose one oxygen. So this part will connect with another H. By means of this, we can get the aldehyde, right? Aldehyde. And the second step, if we continue to provide the hydrogen, this hydrogen will get out the second oxygen. These two bonds will break one bond, and another bond will connect with another hydrogen to produce the alcohol, OH. And this Okay, and another electron will attract another hydrogen. Okay, at the end of this reaction, we will get the primary alcohol because it connects with two hydrogen, right?
Mm.
It's just a reverse reaction of the oxidation of the primary alcohol's oxidation, and a reverse reaction is a reduction of it. So this is the first one. The second one is this one, ketone. Ketone 2 plus the hydrogen, we produce a secondary alcohol. So just these two kinds of the reduction, they are all the reverse reaction of the oxidation. Do you have any question about this one?
No.
Okay. We'll move to the next part. The third kinds of reduction is the reduction of unsaturated compounds. Could you explain what's the unsaturated compound?
Unsaturated. Unsaturated may have the double or triple bond.
Yeah, you're right. Quite right. The unsaturated compounds mean that the compounds with double bond or triple bond, right?
Yeah.
Just like this one. This is the unsaturated bond. So how to reduction it? The reduction we means get hydrogen or lose oxygen.
Through break the bond to the hydrogen or oxygen.
And the hydrogen will collect like this, right? This is a reduction. So the first one is the alkene. For alkene, we know it has a double bond, right? Alkene. The alkene and the alkyne. Alkyne, it has three triple bond. Okay. If we want to add the hydrogen to it, we mean break the multiple bonds to add hydrogen to it. So this action, we call it the addition reaction, which means the break multiple bonds to add another element. So the chemical reaction like this one. This is the alkene, CnH2n, and plus the hydrogen to produce the alkane, right?
Yeah.
Alkane. Okay. So the Lewis structure like this, the double bonds will get the hydrogen. And we see the reaction, there's the Ni as a catalyst, and the temperature is about 150 centigrade. And we get the propane. Any question about this section?
No have.
we said that this voltage actually is the potential difference, right?
Yeah.
Potential difference between these two half cells. So actually we can set one standard voltage, standard potential. So any half cells potential we can compare with this one standard potential. And so we can get the absolute. Actually, it is also the relative potential, but we can see it is absolute potential of this half cell. So how to set the standard potential? We use this one, the standard hydrogen electrode. So we can see it's just SHE, right? SHE. Do you know SHE? The girls group, right? A girls group. Okay. So standard hydrogen electrode. We use this half cell as the standard half cell. We set its potential as 0 potential. So in this part, we will see how to set the SHE. We use this one. We use the hydrogen half cell. This one. We use this reaction to produce the standard hydrogen electrode, and its standard potential we notate like this one, the uppercase E with the small minus circle it. Okay. So actually, every half cell have its electromotive force. We write it like EMF as its voltage or as its potential of it, and we set the SHE's potential as 0, and the SHE we set like this one. So you need to recite this graph. We will look at it. The first one. Here is the electrode. The electrode we built it with the platinum. And the second, this solution. The solution is the acid solution, and it's containing 1 mole per liquid hydrogen plus. Here is a pipe. We use this pipe to inlet the hydrogen gas. The hydrogen gas will at 298 Kelvin and 100 kPa. This is actually the 25 centigrade, and this is 100 kilopar actually is 1 atmosphere, right? 1 atmosphere. So this is the standard condition. At this condition, we inlet the hydrogen gas, and the hydrogen gas will into this solution, and this solution, it will occur the reaction like this one. The hydrogen becomes the hydrogen ions with 2 electrons, and the reverse will occur together. It will be at the equilibrium. So the reaction is like this, and this structure will get its own EMF. The EMF we set it as 0 voltage, 0 volts. So this is the SHE structure. Okay, do you have any question about this one?
So it's as the hydrogen of the stand.
如果你也可以就是问中文哈，我们后面就是那个能用英文就用英文，实在受不了你就说中文也可以啊。你什么问题啊？这个地方？
就是它 SHE 它是
嗯，
嗯，它是不是就一个标准的那个做一个标准？就
对，就是我们人工设置的零点零伏
啊
的那个装置，所有其他装置与它相连，这样测出来的电压呢，其实就是另外一个装置它的电压了，因为这个是零伏，对吧？
啊
其他车子我们测的这个都是 voltage 的 difference，都是它俩之差。所以如果设成这个是零伏的话，任何与它相连的那个产生的 EMF，我们就都可以算出来了，对吧？测
啊
的就是，所以设这个标准是很重要的，对不对？
啊
这个标准是很重要的。还有这个标准，注意啊，它的条件哈，就是有这个25摄氏度一个大气压，对吧？所以你
啊
那天问我是不是所有的那个电池，当时我们测的那个1.1伏啊，那个都是这么多？我说不是，对吧？我说是有条件的，
啊
就测出来是在这个条件下哈。如果比如这个时候，比如说是100摄氏度的，然后2个大气压了，那个结果肯定是不一样的，
啊！
肯定不一样的。OK, we'll move to the second part. And in this part, we will talk about how to measuring the standard electron potentials. Electrode potentials. The the method to measuring the to measure the standard. In this part, we will talk about how to measure the EMF of this one. The method to test it is to collect it with the SHE, and we use a voltmeter to test the potential difference. And this one, this record, actually is the potential of this part. So we use this method to test the standard electrode potential. For example, this one did the SHV, and this one you use the copper solution. And this copper solution, we immerse the copper strip into the copper solution. And the copper solution, we get the concentration is 1 mole per liquid. If we combine these two half cells together, collect them together with the salt bridge and the wire, we can have the voltage like this one, 0.33 volts. So this is the standard electrode voltage of this part. So we have measured the the standard electrode potential of the half cell. And we will write like this one. We record it is 0.34. So we wrote the half cells equation like this one, and we get the cells equation like this one, and we write the E cell equals this one. This is the potential difference for this whole cell, right? And actually, it's the potential of the copper ions because the other part is zero voltage potential. And And we will have the second example. We collect the zinc half cell with the SHE. We get the voltage like this one, minus 0.76. And we see that in this part, the zinc will lose electrons. In the previous example, we get the hydrogen to lose electrons and the copper to accept the electrons. So in this part, we can see that the zinc's voltage will be the minus. And we set the cell's equation with its E cell. We need to pay attention to this minus signature here. So we can get a summary. If one element if one half cell collects with the SHE, if this cell will lose electron, it will get the negative voltage. If it can get electron from the SHE, it will get the positive voltage. So we could know that if this value is greater, it means this half cell could more readily get electrons, right? So it is more useful to reduce, and it is a more powerful oxidation agent. Could you understand it?
Yeah.
Okay. So we get a summary table here. For this zinc, we know this one, right? This one. Actually, for the zinc, we get the E cell as minus 0.76. For hydrogen, we get 0. This is the SHE. And for copper ions, we get the positive 1. And the H silver, we get the positive 0.8. So this is the E cell. We call it the standard reduction potential. Because this pole, we assume they will get electrons, it will reduce. So we call it standard reduction potential. If it is positive, it is actually reduced. If it is a negative, it actually the oxidation instead of the reduction. Therefore, we get this table value, and we know that in this part, for the ions, it means at the bottom of the table, the elements is more powerful to reduce to get the electrons. On the other part, this part, it means the elements, if it at the head of this table, we know that it is more powerful to provide electrons. So it is a good reducing agent. Okay, just this one. For this table, we need to explain something. The first one, that all E minus values refer to the reduction reaction. So all these are reduction reaction, and this E minus means the reduction reactions values. Second, the E value do not depend on the total number of electrons, so do not have to be scaled up or down with the stoichiometry of the equation for reaction. What does this mean?
So the E is not changed if the equation of the reaction had changed is a tone number.
Actually, it only depends on the concentration of the ions, right? Ions. We only pay attention to the ions concentration. Don't pay attention to the electrons. For example, if we have ions Cu2 plus and another one is Cu1 plus, we know in this half cell it will have 2 times electrons. If all of them, if both of these solution has 1 mole per liquid concentration, we know that for the first part, it will get two more electrons, right? And the second one only get 1 more electrons. This sentence mean that we don't pay attention to the electrons, we just pay attention to the ions. So you don't need to divide the first one with 2 to make the 1 more electrons. We don't need to do this one. We just pay attention to this one. It's okay. Okay, the third one. The more positive E value for the half cell, the more readily it is reduced. Okay. So we mean at the bottom, this part has more powerful to be reduced. The first one, electrons always flow through the external circuit in the voltaic cells from the half cell with the more negative standard electrons potential to the half cell with the more positive electron potential, which means the two half cells, we know that the electrons only comes between this wire, this external circuit. The salt bridge only transfer the ions. The electron only exists in the external circuit, and we know that the direction of it is from the negative pole to the positive voltage pole. So from this one, we know that it will come from the zinc one to the copper one, right? Or not from the copper pole to the ink pole. Okay, we will OK，这个就下次了吧？这个
好，
今天就这样吧。行，那个作业到时候我发给秦老师，秦老师转给你吧，好吧？
拜拜。
好了，今天就好，再见。